Welcome to this YSL Excel VBA tutorial. This video is going to explain how to create a pivot table connected to a SQL Server database. So a big part of the video is going to talk about how you can connect to SQL Server databases using Excel's Workbook connections. We'll explain how to create one of those manually, and then how to write code to do it, and how you generate the connection string to point to the correct database. We'll then explain how you can use or create a pivot cache, which uses the external source that you've created, before we finally link to a SQL Server table and generate a basic pivot table based on the data in there. We'll take things a bit further and talk about how you can create SQL Server views, which is a neat, simple way to bring together data from multiple different tables in the database into a single Excel pivot table. And then just to wrap up the video, we'll explain how you can write your SQL queries directly in your VBA code. So I'll have a really quick overview of writing basic SQL select statements. So quite a bit to do here, let's get started. We'll get started by writing some simple code to generate a basic pivot table based on some Excel data. This will just give us a nice starting point that we can easily modify to connect to our SQL Server database later on. We'll use exactly the same file we've used for the past couple of videos here, this basic movies workbook. If you don't already have a copy, there'll be a link in the description below the video if you're watching it on YouTube, or above the video if you're watching it on the YSL website. And once you've downloaded and opened it up, we'll head straight to the Visual Basic editor, and then in there we'll insert a new module. I won't bother renaming the module. What I will do is create a basic subroutine called create basic pivot. Now we've done this a few times over the past couple of videos, so I won't go into too much detail here, but just to get started, let's declare a few simple variables. One of these is going to hold a worksheet, and that's the object that the pivot table will sit on when we finish creating it. One will hold a reference to a pivot cache object, which, as we should know by now, is absolutely vital for creating a pivot table. And then finally we'll have one that will hold a reference to the pivot table itself. The first thing we'll do then is create the pivot cache. So I can do that by saying set PC equals this workbook dot pivot caches dot create. Now there are two parameters I need to fill in here, the source type and the source data. So I'm going to set the source type, slightly confusingly, to Excel database. Even though we're referring to internal Excel cells here, the property or the value we use here is Excel database. We'll use Excel external later on in the video when we connect to our SQL Server database, but for now Excel database is the one we need. The source data then, because these are internal Excel cells, we need to refer to the cells that contains all the data. So that's all the cells on sheet 1 on my movies worksheet, WS movies. Now although I can use a range reference here, Microsoft's recommendation is to use a string of text which represents the address of the cells that you want to base your data on. So the simplest way to do that, I think personally the most robust way to do it, is to say wsmovies.name. So WS movies of course is the code name for the worksheet, and then I can concatenate that with an exclamation mark, and then I can concatenate the rest of that with the cell references of the cells on the movies worksheet that contain my data. So I can say WSMovies dot range A1, which is the top left hand corner of where all the data sits, dot current region dot address. So that will concatenate safely all the cell references on the specific worksheet that my data is contained within. Now that I've got the pivot cache, I can easily create a pivot table based on it, but I'm going to start by creating the worksheet first. So let's say set ws equals worksheets.add, and then we can set our pivot table variable to refer to a new pivot table. So set pt equals pc.createPivotTable. There are several parameters I can fill in here as well. The only two I'm going to provide here are the table destination and the table name. So the table name, as you can see there, is optional, but I always think it makes sense to have a specific name for the tables in case you want to reference them later on. So table destination is going to be cell A3 on the worksheet that I've just created. So that's ws.rangeA3. I'm leaving a bit of space at the top of the sheet for any page fields that I might add in later on. Then the table name, if I type in a space underscore, table name, I'm just going to call this one something simple like movies pivot or movie pivot. Now I could just leave the pivot table empty and rely on the user to fill in the various fields they want, but just for the purposes of demonstration I'm going to add a few basic fields to the 4 areas of the pivot table. So to start with I'm going to say pt.addFields, and this will let me relatively quickly add in the row field, column field and page field I'm going to use. So I'm going to specify these individually on separate lines. So row fields is going to be colon equals studio, so that's the name of the studio column in the original worksheet. The column fields next column fields, colon equals, I'm going to make this equal to the certificate column. So there are fairly few of those. And then one more, I'm going to set the page fields to be equal to the country column. I'll also add in a data field, but I'll use a slightly different method for this. I'm going to use the add data field method, and again there's a couple of parameters to fill in. The one compulsory one is the field parameter, so I can make that equal to, it's going to be a reference to an actual pivot field object. It's not just as simple as a string of text like the row, column and page fields. I've got to say something like pt.pivotFields, then open some parentheses and then enter the name of the field I'm interested in. So in this case it's going to be the runtime field, and then I'll also choose a different function for this. I'm going to use a space underscore and set the function to be equal to one of the Excel consolidation functions. A nice easy way to see this is to refer to the Excel consolidation function enumeration first, and then you can pick from a specific list of available functions. I'm going to use the average function for this example. What I'm then going to do is just apply a basic format to the result of that data field. I'm going to say pt.datafields datafields1. I've got to reference the specific data field that I've just added. So pt.datafields.number format, and sadly the IntelliSense breaks down here, but I can still set its value to be equal to 0.00. So that'll just give me a number formatted to 2 decimal places. Okay, so that's the basic pivot table set up. This will be nice and easy to change to our SQL Server example shortly, but just to give this one a very quick test to make sure it runs and generates a pivot table, and that's the sort of thing that we should be ending up with. Now, of course, the whole point of this video is to show you how to create a pivot table based on a SQL Server database, and that means you're going to have access to an instance of SQL Server. If you don't already have one available, then we do have a video series actually that explains how to get hold of a free edition of SQL Server 2016, which is the latest version, how to download it, how to install it and configure it, and a little bit about database design principles as well. So if you don't already have a SQL Server instance, then this video series here will explain exactly how you can get to the point where you can install the database we're going to be using. If you've already got SQL Server installed, it doesn't matter if it's not SQL Server 2016, this will work in any version of SQL Server, and then you'll need a copy of the database that we're going to use. So you can get hold of a copy of that. Again, I'll put this link in the description either above or below the video, wherever you're watching this, and if you browse over to the WiseOwl website, there's a specific exercise you can browse to that will give you access to the script that will create the movies database we're going to use. So on that page you can look for the this file link, and if you click on that, depending on which browser you're using, you'll get an indication that the file is being downloaded. So in Google Chrome, as I'm using here, it shows me in a little box in the bottom left hand corner that the file's been downloaded. What I can then do is open up that file in the folder, and then I'm going to unzip it. So I'm going to have to right click and extract all the files stored inside that zipped folder. So if I right click on it and choose extract all, I can then just click extract to extract it to a new folder, and then it might make sense if you open up that folder. There are 2 different versions of the database you could use. I'm going to use one here called updated movies database, so generate updated movies database. What I'm going to do is copy that file into a different location on my computer just to make it slightly easier to find. So I've actually already set up in the root of my C drive a databases folder. It's the same one that I used in the previous video actually for my Microsoft Access database. In fact, it's still sitting there. So I'm just going to paste that script into that folder, and then I need to actually use that script to generate the database. Okay, so this is the point at which you'll need access to an instance of SQL Server, and as I say, if you need some help with getting that set up, then that's the series of videos to watch. So I'm going to assume that you've already got to the stage where you've got access to SQL Server, and you've got an application installed on your machine called SQL Server Management Studio. So I've got a couple of different versions of this installed. I'm going to go for my SQL Server 2016 SQL Server Management Studio application. When I open that up, it's going to give me access to any SQL servers that I have the credentials to access. I'll first of all need to connect to a specific server, so mine's already set up to point to an instance of SQL Server on this local machine called SQL 2016. So if I have that option selected and click connect, I'll now have a list of databases and various other objects which belong to that server. So to create that movies database, if I just have a quick look in my databases folder, it hasn't got anything other than the default system databases that are installed alongside SQL Server. So what I'm going to do is open up the script that I've just downloaded. So the simple way to do that is to click on the open button, or I can of course press Ctrl and O, and then I'll need to browse a way to find where that file is stored. So I stored it in the root of my C drive in my databases folder. So I open that up, and then just simply double click on the SQL file to open up the script which will actually generate this database. Now you don't really need to understand anything about this code. We've got video series on how to write SQL code. You don't really need to understand any of that. All you need to do is making sure you've clicked somewhere inside this script, and then simply click the execute button or press the F5 key. It's kind of a lot like running a subroutine in the VBA editor, I suppose. Eventually you should get a list of messages saying that things have worked, or it looks like things have worked. Hopefully you don't see any messages highlighted in red here. And then if you want to see if the database has appeared, what you'll need to do is refresh the databases folder. If you right click the databases folder and then choose refresh, we should find that the movies database is now sitting there. Feel free to have a quick look at some of the objects in there. This is kind of similar to the setup of Access. If you watched the previous video, we saw there was a database window that listed out all the tables in the database. So if I expand the movies database and then the tables folder, I'll see a list of all of the tables that I've got access to. Now at this point you can happily close down the script that you used to create the database, and what we're going to do next is write some code in VBA that's going to connect to a specific table in this movies database. It's going to be the film table, or TBL film. Now I can't do that just at this point because I don't yet have a connection available which talks to this database. So that's the next job actually. I need to create a connection to the SQL Server database, and specifically this film table. Later on in the video we're going to get into how you write code to do this, but just to get started I'm going to show you how you can set up a connection to that database manually. So heading back into the Excel workbook, if I just make sure that I've clicked away from the pivot table and then head to the Data tab in the ribbon, we saw in the previous video, if you watched that one about connecting to Access, that you can use the Connections dialog box to add a connection to an Access database relatively straightforwardly using a simple wizard. To do the same thing with SQL Server, what we need to do is choose to get data from other sources first. So using the Data tab in the ribbon, I'm going to choose this option here that says From Other Sources, and then the top option in there is From SQL Server. So if I select that option, it opens up a slightly different wizard. The first thing I've got to do is type in the server name. Now ordinarily you'll find this listed at the top of the Object Explorer window in SQL Server Management Studio. So the full name of my server is desktop, and then this silly sequence of code numbers and letters which refers to my local machine, then a backslash, and then the name of the server itself, or the instance of the server, SQL 2016. Now because this is a local instance of SQL Server, I've got a quick shortcut way I can write this. If I simply type in a full stop followed by a backslash, that's a shortcut way to refer to the local machine. Then all I need to do at that point is type in the name of the instance, which is SQL 2016. I'm going to use Windows Authentication, which is how I've got my SQL Server set up, and that will make a lot more sense if you've watched the previous video series on SQL Server 2016. And then I'm going to click Next, which will give me access to all of the databases that belong to that server. So if I click on this drop down list at the top, I should find that I've got access to my movies database. If I select that, then I've got a list of tables I can connect to, and the specific one I'm going to go for here is the film table. So if I select the film table and then click Next, I now get the option to save the connection details in a separate file, an ODC file, an Office database connection file, I believe. So what I'm going to do is give this file a sensible name first of all. I'm going to call it SQL 2016 Movies TBL Film. That's fairly descriptive. The name of the server, the name of the database, and the name of the table. I'm also going to give it a slightly shorter name as well. So rather than calling it this fairly long-winded name, I'm just going to give it a friendly name of Movies. At that point I'm just going to hit the Finish button, and what that will do is save the connection file, saving the information that I've just set up to point to that database. But it will also launch another dialog box asking me to import some data from that SQL Server database, and I don't really care about doing that at this point. The only reason I wanted to go through that wizard was to create the connection object. So in this case I'm just going to cancel out of the import data dialog and just have a quick look at the connections page, because now we'll have a slightly easier job to add a brand new connection pointing to that SQL Server database. So to create the connection itself, I can happily click the Add button, and then I get a list of all the connection files currently stored on this computer, which should now just be the one that I've just created, this movies file. So if I have a quick look, if I browsed for more, that will take me to the folder where all of my data files, my ODC files, are stored. You can see the one that I've just created here, SQL 2016 Movies TBL Film. So it's listed with its friendly name in the connection files on this computer, so all I need to do is select this and then click Open to generate my new connection. And there it is, it's sitting there right now, and I can now reference this connection to get data from that SQL Server database. We're going to come back to this dialog box a little bit later on to steal some details for that connection, but just for now I'm going to click the close button, and remembering that the connection name is called movies, heading back to the VB editor, we'll write a subroutine that uses that movies connection. Let's start by making a copy of this subroutine, so I'm going to copy the entire thing and then just paste it in immediately down below. And of course we'll need to update its name. We can't have two subroutines with the same name in the same scope. So let's call this something like create pivot using SQL connection. And then there's a few things we'll need to change in this particular example. First of all, we're not any longer connecting to an Excel database. What we're connecting to this time is an external database. So the first thing to do is change the source type of the pivot cache that we're creating so that it's using an Excel external source. The source data then of course can't point to the cell references in the Excel workbook. So let's remove all of that, and one simple way to do this is to refer to the connection object that we've just created. So what we could do is refer to this workbook dot connections, open some parentheses and some double quotes, and the friendly name of that connection was called movies. Then we can close the double quotes and close the extra set of parentheses. So that will work quite neatly. It might make a little bit more sense, however, to store a reference to this connection in a variable, just like we did in the previous video for access. This will just make life slightly easier when we start to modify things later on. So I'm going to declare a new variable towards the top of the procedure, which I'm going to call cn as. Then, although I'd expect to look for a connection object here, a connection object in the connections collection, the actual specific type or specific class of object here is called a workbook connection. So, having declared that variable, what I can do is say set cn equal to, and then I can just cut and paste the code I've typed in down here. And if I paste that in, I can now set the source data to refer to the connection object. That's a slightly more elegant way to do things, and as I say, it'll make life slightly easier when we start to modify this code for more complex examples later on. The other main thing that we're going to have to change here are the column names that we've referenced. So the field names stored in the Excel workbook aren't the same as those in the SQL Server table. If you want to find out what the SQL Server table names are, you can use SQL Server Management Studio to find out. So if you find your film table and you click the plus symbol to the left of that, there's a separate folder there called columns, and in there it will give you a list of all of the column names for that specific table. So you'll see that we don't have a simple country column or a studio column. They're called film country ID, film studio ID, runtime minutes is called film runtime minutes, and there should also be one in there called film certificate ID as well. So to make that work, let's just switch back to the VB editor, and rather than studio it was film studio ID, rather than certificate it was film certificate ID, and rather than country it was film country ID. The runtime column as well was called film runtime minutes. Let's make that change, take away the space, film runtime minutes, and at that point everything is set up and ready to go. So you can see it's a fairly small amount of changes required to point to an external database. As long as the connection exists, the code is pretty much the same as connecting to an internal Excel table. Just to give this one a quick try, then if I run this subroutine just to create the new worksheet and have a quick look back in the movies workbook, I've now got a new pivot table, but this one's based on the SQL Server table, which you can hopefully tell based on the field names or the column names that appear in the pivot table field list. Now, one of the big differences between the data we get from the SQL Server table and what we get from Excel is the fact that we've got ID numbers rather than actual studio names and certificate names or country names, and we're going to deal with how to solve that problem a bit later on in the video. For now, what I'd like to talk about is how you can create a connection from scratch. So this particular technique we've just looked at relies on the fact that that movies connection exists in the first place. What if that wasn't already there? What we're going to do is create some code, or write some code that's going to create a new connection object from scratch. So to make that work, I'm going to switch back to the Visual Basic Editor, and I'm going to create a copy of the previous subroutine, which I can paste in just immediately down below, and I'm going to say create basic pivot and SQL connection, indicating that we're going to create the connection and the table as well in the same procedure. Now, the most important property of the new connection we're going to create is called its connection string. This is quite a long, complicated string of text, which you may remember from the previous video how complicated the access connection string was. This will make life easier if we create a separate variable to hold the connection string. So I'm going to say cn string as a string. It really is very much just a string of text. And then I'm going to say cn string equals, then open and close a set of double quotes. Now, certainly the simplest way to create a connection string isn't to type it in from scratch, just trust me on that. The simplest way to create the connection string is to copy and paste it from an existing connection. So we already have a connection to our SQL Server database. If I switch back to the Excel workbook and then head to the Data tab in the ribbon, choose Connections, I can see the properties of my movies connection by selecting it and hitting Properties. If I then look on the definition page of the Connection Properties dialog box, here's the connection string itself, and you can see now hopefully why I wasn't going to attempt to write that out from scratch. If I just change the width of that dialog box just to see the whole thing on one single line, that's not necessary by the way, it just makes it slightly easier to see how much information is included. So all I'm going to do at this point, knowing that this connects to my SQL Server database, is I'm going to copy all of that to the clipboard and then simply cancel out of this dialog box and close down the workbook connections, and then switch back to the VB editor, and then inside those double quotes I'm just going to paste in the connection string that I've just copied. Now there's one really important addition I've got to make to this connection string for SQL Server. When I'm creating connections to external sources like this, I'm creating something called an OLEDB connection. You can see the words OLEDB, Object Linking and Embedding Database, I believe that's what that stands for. But it's important to indicate to the connection string when you create a connection manually that it is indeed an OLEDB connection rather than a different type, such as for instance an ODBC connection. So to indicate that, you've just got to add a couple of characters, a few characters just to the start of the connection string. It's OLEDB followed by a semicolon, and that's enough to indicate that that particular connection string is an OLEDB connection. What I can then do is modify the line which refers my connection variable to an existing connection. What I'm going to do instead is say this workbook.connections dot add. You can say add or add to depending on which version of Excel you're using. I'm using Excel 2013 here, so the method is called add to. But if you're using Excel 2010 or earlier, I believe, then it'll just be add. If I can then open a set of parentheses, you'll see there's a range of different parameters that I've got to fill in. So most of these are compulsory, so I'm going to set the name parameter first of all. So the name is just the name of the connection that I'm using. I'm going to call this one, name colon equals, beg pardon, and then set this one to be something simple like movies SQL. Then if I type in a comma and a space underscore, the next one will be description. Now description is a compulsory parameter. I've got to fill something in here, but passing in an empty string is more than enough for the description. I don't really require a description for this particular connection that I'm creating. The next parameter along, connection string, of course, that's the most important one. So I'm going to say connection string equals, or colon equals, and I can refer to my cn string variable nicely and easily. And then one more that I've got to fill in, which is command text. So the command text is the name of the table, in this case, that I'm trying to reference. So we saw earlier on that we were referring to our TBL film table. Now the way that you reference these tables in SQL can be somewhat more complex than this, but in this particular example, TBL film is more than enough to reference that particular table. There's one last thing to fill in here as well. This is an optional parameter, but I think it's worthwhile specifying here. We'll see what other options we've got for this final parameter a little bit later on. The name of the parameter is called L command type or CMD type, which I think I mentioned in the previous video. I'm sure is a typing mistake, because what it's really referring to is one of the Excel CMD type enumerated constants. So Excel command type, I'm sure that's just a typo, that should be Excel command type there, but anyway, bearing that in mind, we've got Excel command types. These are the list of command types you've got available. You may see a slightly different list to the ones that I have here. Again, depending on which version of Excel you're using, you may not have the DAX option available. The one that we're going to use in this case is just Excel CMD table. We're just simply passing in a table name. Okay, so having done that, if I can then close the parentheses, that's created my new connection object, which I'm referencing in the pivot cache create method. So once it's been created, that pivot cache will use that connection to create the pivot cache. So let's have a quick go at running that one. If I hit the execute button, have a quick look back in the Excel workbook, I should now have yet another worksheet containing the same list of data, same arrangement of pivot table, but this time using a connection that I've generated using code. Now, one thing that's just worthwhile bearing in mind about these connections that we're creating is that unlike the pivot caches, you may remember from the first video we made on pivot tables that when you delete either a worksheet or a pivot table, the pivot cache corresponding to that sheet or table is deleted as well. But that's not true for connections. If I just switch back to the connections dialog box just briefly, you'll see I've created my new movies SQL connection. If I close that down and go back to the VB editor and then just run that subroutine 2 or 3 more times to create a few new sheets, and what we should see if I switch back to Excel and look in the connections page is that I've got a whole great big long list of new connections. So even though I've said to create a connection called movies SQL, it creates a numbered list if that one already exists. So just to demonstrate that those connections remain in place when I delete the sheets, the last one I've created here is movies SQL 4. If I close that down, if I delete the sheet that that's associated with, and of course deleting the pivot table and the pivot cache as well, if I then switch back to the connections list, the connection itself is still there. That's kind of sensible behaviour, I suppose. If you wanted lots of different tables connected to different data sources, or even indeed the same data source, but each data source or connection could have the ability to be updated independently of the others, that's sensible behaviour. But if we're going to be deleting lots of worksheets, then we don't want to leave these connections in place. So what we're going to do is write a couple of quick simple routines, same as we did in the previous video, just to tidy up and delete the sheets, except for the movie sheet, and then all the connections as well. So let's just close that one down, head back to the VB editor, and I'm going to insert a new module for this, just to write these 2 extra quick subroutines. So we've run through this a couple of times previously. I'm just going to write a couple of quick subroutines to delete all sheets but the movies sheet. So let's have a quick go at doing that. I'll declare a variable called ws as a worksheet, and then I'm going to say application.displayalerts equals false because I don't want to see lots of error messages popping up when I do this. And then I'm going to have a for each loop for each ws in this workbook.worksheets. Next ws, and I'm going to test in there if not ws is ws movies, then ws.delete. And that will get rid of all the worksheets that I don't need, so I'm going to quickly run that one, and that will get rid of all the sheets except for the movies sheet, which you can see. And then if I look back at the connections page, I'll still see that I've got all the connections that were related to those pivot tables and pivot caches. So the next job is to write a routine that deletes all of those. So again, back in the VB editor, let's have a quick subroutine that's called delete all connections. And then we can say dim cn as workbook connection. And then for each cn in this workbook dot connections. Next cn. And then inside the loop I can simply say cn.delete. And if I give that one a quick run by hitting F5, then switch back to Excel, have a look in the connections page, now all the connections are tidied up as well. Just before we move on talking more about connections, I want to quickly go back to the previous routine that we wrote to create a new pivot table. I just wanted to mention a little bit more about naming the tables in a SQL Server database. So we use the simplest way possible here. We just put in the table name. If I switched back to the SQL Server Management Studio application, you'll see that the name of each table in this list is preceded with the letters DBO dot. Now DBO refers to something called a schema, which is an organizational and security tool in SQL Server. There's a little bit more about these in the video series I mentioned, just in case you're interested about what schemas are. Now, the reason I mention schemas is because you might have more than just one schema in the same database, and if your table belongs to a different schema than the default one, which in this case is DBO, then you should also use the schema name when you reference the table. It's also worthwhile mentioning that you can refer to tables in multiple different databases on the same server, so I could precede the name of the schema with a reference to the database itself. So just to quickly show you how that would work in VBA terms, in the command text where I refer to TBL film, I could precede it with the name of the schema, so in this case it would be dbo.tbl film. If I were to run that one, I'll end up with a new worksheet, and again that gives me the exact same list of data that I've seen previously. If I switch back, as I said, I could also precede this with the name of the database, so I can qualify the schema name with the database name, so that would be movies.dbo.tbl film. If I again just run this one just to demonstrate that this one works, and then switch back to the workbook, you'll see that I've got a new pivot table, again using the exact same list of data, but with a slightly different way of referencing the table name. So it's just worthwhile mentioning and knowing that you can reference and sort of qualify your references to table names in SQL Server with the name of both the schema and the database to which the table belongs. One more thing to talk about in terms of connections. Obviously in this particular example we explicitly created a connection that we then used in the pivot cache's create method. It's also possible to create a pivot cache that will implicitly create a new connection when it's required, so you don't have to write out this separate code to create the new connection explicitly. So to demonstrate that, I'm going to create a new copy of this subroutine. So I'm going to copy the entire thing and then paste it in down below, and then just update its name so that it's called something like create basic pivot and implicit SQL connection. What I can then do is start stripping out bits of this code. So first of all, I don't need my variable that refers to the connection object anymore. I can delete that entirely. Likewise, I can get rid of this entire chunk of code that creates the new connection. I'm going to do that implicitly in this particular example. I'm also going to then modify the way the pivot cache is created. Because I haven't created the connection object to reference, I can't set the source data at that particular point. So I'm going to get rid of that particular argument for the source data parameter, then just tidy things up a little bit by bringing everything back to a single line. Now what I need to do, of course, is once the pivot cache has been created, I've got to point it to the correct connection. But to do that, I can just set a few basic properties of the pivot cache object. So I can say pc.connection equals, and all that it requires is the connection string that I built earlier on. So I can say cn string, and that will set the connection to the correct place. I can also then specify other things that I specified earlier on when I created the connection, so I can specify its command type, and I'll get a list of all the possible command types. We've seen this previously. It's still a table that I'm referencing, so it's Excel command table, and then I can also say pc.command text. So in this case it's going to represent the name of the table that I'm referencing. So I could say movies.dbo.tbl film, but it's just simpler and easier in this case just to say tbl film. So just to demonstrate that that will work in just exactly the same way, or will result in exactly the same results at least, if I just run this subroutine at this point, I'll end up with yet another new worksheet, and it's got exactly the same list of data that I had in before when I created the connection explicitly. Just to quickly tidy up then at this point, I'm going to go back to module number 2, and I'm going to delete all but movies. And just before I delete all the connections, it's worthwhile seeing that when you create an implicit connection, it creates one with a really generic name, just called connection. But I'm going to get rid of that and all of the other ones as well, so I'm just going to run this subroutine. Now if you can create connections implicitly and they have these generic default names, how could you find out which connection is being used for a particular pivot table or pivot cache? What I'm going to do is head back to module number 1, and I'm going to run the previous routine one more time to create just one extra worksheet with a single pivot cache, a single pivot table and a single connection object. What I'd like to do then is write another routine from scratch that will get references to all those objects. So I'm going to create a new subroutine called something like getRef or getReference to connection. I'm going to use a few variables in here. Let me just give myself a bit more space to scroll things up so you can see things a little more clearly. So the 3 variables I'm going to create are a PC as a pivot cache, and then dim pt as pivot table, and then also dim cn as connection. Sorry, beg your pardon, workbook connection. What I'd like to do next is get a reference to the pivot table of one of the cells on the worksheet that I've just created. So I'm going to refer to range A3, and I'm going to try to return its pivot table property. So to do that, back in the VB editor, I'm going to say set pt equals range A3. So of course this relies on the fact that I've got this worksheet selected. So range A3 dot pivot table. So the pivot table property just returns a reference to the pivot table object that that cell belongs to. It's pretty straightforward. I can then do a similar thing for the PC, the pivot cache object. Every pivot table must be based on a pivot cache, so I can set the PC equal to pt.pivot cache. And this is a method that returns a function technically that returns the pivot cache object, but similar principle. Every pivot table has a pivot cache, and you can return a reference to it. Now every pivot cache, well not every pivot cache is based on a connection of course, but this particular pivot cache is based on a connection. So I can set cn equal to pc.workbook connection. So pretty straightforward. I can of course create connections, then a cache, then a pivot table, but if I want to work the opposite way around, this is how I can do it. One of the really useful things about this technique is that it allows you to modify an existing connection that a pivot table is based on, rather than just having to tear down the entire thing and build a completely new one from scratch. So if I wanted to modify anything about my connection object, I'm going to use a little with block for this. I'm going to say with cn dot, and specifically I'm interested in the OLEDB connection. We talked about OLEDB earlier on, so I want to modify that particular type of connection for this workbook connection object. So with cn.OLEDB connection, I'm going to say end with. I've now got access to all of the properties that I set up earlier on. So I've got, for instance, I can change the command text. So I can say command text equals, and let's change it to the name of a different table in that database. So there's TBL actor, for instance. I could also, if I wanted to, change the command type. There's no point in doing that in this particular case because the command type is the same. It's still a command table. I could also change the connection itself, so I could say .connection and make that equal to a completely different connection string. But again, there's not much point in doing that. I've only got this one single database that I'm pointing to in this particular example. Once I've made those changes, I can then refresh the connection. So outside of the with block, I can say cn.refresh. And what that will do, of course, is make my pivot table lose any reference to any fields that were in the original film table. So what I might want to do is modify the fields for the pivot table. So I could then say pt.add_fields, and I'm just going to add in some basic row fields this time. The actor table has got a column called actor gender. So I'm going to say actor gender. Row fields is the first parameter, so I don't need to reference it by name. And then I could maybe add in a data field as well. I could count how many actors there are in each gender. So I can say pt.add_data_field, and then I can say pt.pivot_fields, open some parentheses and double quotes, and then I can say actor gender. Sorry, beg pardon, actor ID is what I was going to say. And then I can use the Excel consolidation function. I'm just going to count them. So Excel consolidation function .excel count. Okay, just to demonstrate what that looks like when it's running, I'm going to restore now my VB editor window, and then you can see clearly the pivot table sitting in the background. If I then use the F8 key to begin stepping through, the first few things that will happen, of course, won't make any difference to what you can see behind the scenes. And even when I start changing the command text of the connection, that's not the point at which the pivot table itself changes. It's when the connection gets refreshed that my pivot table will break down completely. If I hit the F8 key here, the entire pivot table falls over. It can't access any of those fields. But if I use the F8 key then to add in some available fields like the actor gender and then the actor ID, I'll find that my pivot table still works, just using its different connection, or its modified connection. Nice way to see the results here is to click inside the pivot table. You can see that the pivot table field list now gives me access to all the fields from the actor table. Okay, so at this point I'd just like to go back and talk about the fields that we were returning from our film table from the SQL Server database. If I bring back the VB editor and then just maximize it, I'm going to run this previous subroutine again to create the pivot table with the film studio ID and certificate ID and country ID. If I then look at the results, as we saw earlier on, we don't get the country name or the certificate name or the studio name, or we get the ID numbers of those particular columns. That's because that's the exact data that's stored inside the table in SQL Server. If I go back to SQL Server Management Studio and I right-click on the film table and then I choose to select the top 1,000 rows just to see what's in there, I will see that the results return columns worth of numbers. So for instance, the director ID isn't stored as the actual director name, not Steven Spielberg for Jurassic Park. It's stored as the ID number 4. The actual value for Steven Spielberg is stored in the director table. If I looked at the director table and right-clicked on that and choose select top 1,000 rows, then I'll see that director ID number 4 is indeed Steven Spielberg. So the ID number 4 stores lots of information about a single entity. So this is kind of standard relational database design practice. To avoid repeatedly entering the same values in a database, you record each piece of information once, assign a unique ID to that piece of information, and then reference that unique ID whenever you need to make a link to it. That's not particularly useful for our pivot tables, though, is it? If I just close down these two windows that I've just opened, what I'd ideally like to be able to do is in the pivot table return the studio name and the country name and the certificate name. Now, one standard way or simple way to do that for SQL Server is to create something called a view. So the next thing we're going to do is actually back in SQL Server Management Studio to create an object that returns all the relevant details that we're actually interested in. Creating a view in SQL Server is a lot like creating a query in Access. If I just collapse my tables folder first and look for the views folder in the movies database, if I want to create a new view, I can simply right-click on it and choose New View. This gives me a reasonably nice little GUI tool, a graphical user interface tool, to build up my view without having to write any SQL code, although we will get onto that little part a bit later on in the video. So of course the main table I'm interested in here is the film table. I'm going to insert the film table first just by double clicking on it. Then I want to get access to any of the other tables that might have useful data. So for instance, the certificate table I'm definitely interested in, the country table, maybe the director table for later, and the language table and maybe the studio table as well. If I just double click all of those tables, I'll end up with them all inserted into the background. What I can then do is close down the Add Table window, and hopefully what you can see happening here, as well as the obvious graphical part where all the tables are included, I'm actually writing out the select statement, the SQL Structured Query Language select statement that will return all this data. We'll come back to this, as I say, a bit later on. All we have to do now is choose which columns we actually want to return into our pivot table. So starting with the film table, let's have a quick look. I will certainly want to have the film name available, then maybe the release date, and perhaps the film runtime minutes. Well, I definitely need the film runtime minutes for later on, so let's go for film runtime minutes. Seems something slightly odd's happening with my scroll bar. There we go. So film runtime minutes. Then I'll have the budget dollars and the box office dollars and the nominations and the Oscar wins. Then from each of the other tables, all I really need are the name columns. So rather than having the ID numbers, I'll go for the names instead. So certificate name and studio name, country name, director name, and finally language name as well. I make sure that box is actually checked. Without rearranging the diagram too much, it's a little bit difficult to see what's going on here, but maybe I can just rearrange things a tiny little bit just to show you how the certificate column and the studio column are sort of matched up. I can just click and drag to move these tables around. So you can see that these lines are supposed to represent the relationships or the joins between the columns in the different tables. So certificate ID is like a lookup. If you're familiar with the VLOOKUP function in Excel, when I have the film certificate ID of, let's say, 2 stored in this film table, it will look up the number 2 in the certificate table and return the name for that particular value. Likewise for the directors, you can see that the director table is linked to, if I get my scroll bar working, the director table is linked to the film director ID column, so film director ID is linked to director ID. So when the value 4 is stored here, it will look up the number 4 in the director table and then return the director name, which as we know is Steven Spielberg. So, having done that, all I need to do at this point is save the query, or save the view. So I can do that by hitting the Save button, or press Ctrl and S. And then I'm going to give this one a sensible name. I'm going to call it Film View, and then click OK, and I can happily then just close down that view object. If I want to see that it's actually been created, I can open up the Views folder, and if it wasn't there already, I could have right-clicked on the table or on the folder and chosen to refresh it to make sure that it's definitely there. Okay, so now all I need to do is use that view object in place of a table when I create my connection to the SQL Server database. So heading back to the Visual Basic Editor again, I'm going to make a copy of the Create Basic Pivot and Implicit SQL Connection. Let's just make a quick copy of that one. And I'm going to paste that one back in right down at the bottom of the same module. I'm going to change the name of this one so that it's called something like Use SQL View. So something quick and simple, Use SQL View. Now the connection string is still the same, that's still connecting to the same database movies, and the pivot cache I'll need to create as well. The command table is exactly the same, so a view is essentially just a virtual table, so I don't need to change the command type. But the command text I do need to change, so it's not the film table anymore, it's an object called film view. That means now I've got access to different columns as well, so I'm not going to use the Film Studio ID column, I'm instead going to use the Studio Name column. Likewise, Certificate is going to become Certificate Name rather than Film Certificate ID, and then also Country ID is going to become Country Name. The film runtime minutes column is still the same, so I don't need to change that. So at this point, all I should need to do is execute this routine pointing to my film view object. So if I run this one, I'll end up with a new pivot table, but this time I've got access to my names rather than the ID numbers, and you can see that reflected in the pivot table field list. So that technique's pretty handy, but of course it does require the view object to be created in the first place. If you want to give yourself that little bit more flexibility, what you can actually do is just write your SQL select statements directly into your VBA code, just like you can with the Access databases as we saw in the previous video. So to make this work, what we're going to do is head back to the Visual Basic Editor, and I'm going to take a copy of this Use SQL View routine, and I'm going to place this in a brand new module just to keep things a little bit neater and tidier. So I'm going to insert a new module and then paste that code in. I'm going to change the name of it so it says something like Use SQL Statement, I suppose. SQL Query would do as well. And then I'm just going to tidy things up a little bit by going back to module number 2, deleting all but the movie sheet, and then deleting all the connections as well. Then back into module number 3. I want to make a quick modification just as a slightly easier way to test this routine. Rather than making lots and lots of copies of it, I'm going to allow it to accept a string which is going to represent the select statement or the query I'd like to pass into it. So I'm going to declare a parameter called something like SQL string as a string. And then what we're going to do is modify the way this connection works. So rather than using an Excel command table this time, I'm going to get rid of that, first of all, and replace that with a reference to something called Excel command SQL. So this is going to expect a valid, completely fully formed SQL select statement. So that means I'm not going to pass in just a simple table name or view name here. I'm going to refer the command text to the SQL string parameter. So whatever I pass into this procedure must accept a valid SQL string. It also must make sure, of course, that the column names that I'm using for the pivot fields are valid as well, but I'll make sure of that when we start writing the SQL select statements. Okay, so to test this procedure, what I'll need to do is write another subroutine that can pass the select statement into it. So let's create another subroutine just down below at the bottom of this module, and again I'm just going to give myself a bit of blank space to make things a little bit easier to read, and I'll create a quick sub called Test SQL Queries. In here I'm going to declare a simple variable called str as a string, and I'll use that to construct my SQL statements. I'd also like to make sure that I delete all my existing worksheets and connections before I run this one multiple times. So delete all but movies and then delete all connections. Let's just run those two. What I can then do is set my string variable to be equal to my SQL select statement. Now, if you already know how to write SQL select statements, you'll be at a massive advantage here because you can genuinely write any valid select statement that you already know and then just pass it directly into the other procedure to get the same results you'd expect. If you're not sure about writing SQL queries, then of course we've got a video tutorial series on how to do that. So there's an entire series here that explains how to write queries. I'm not going to go into a massive amount of detail here, of course, because we've already written recorded many videos that explain how to make this work. So, just to give you the absolute basics, what I'm going to do is, in the VB editor, I'm going to write a simple select statement that's going to select, let's say select everything from the film table. So I just write select star or asterisk from TBL film. That's probably the shortest, simplest select statement you could possibly write. The capitalization here isn't important, it's not case sensitive, SQL as a language, but by convention you'll have the keywords select and from in uppercase. This is genuinely considered bad practice, selecting every single column from a single table. It's usually more important to be specific about exactly which columns you want. So we'll move on to that in just a moment. But just to demonstrate that this will work, I'm going to quickly comment out some things from my other routine. I want to comment out the bit that adds the row, column and page fields, because I'm not actually passing in the studio name certificate or country names at this point. So I'm just going to comment out that part, and then I'm going to make a call to that procedure, which is called Use SQL Statement. So down at the bottom I'm going to say Use SQL Statement and pass into it my string variable. So, having done that, if I were to simply run that subroutine, I'll end up with a new worksheet, and on there I will have the average of the film runtime minutes, and if I just clicked into that pivot table to show the field list, you can see I also have access to every single column from the underlying table. Now, selecting every single column from a table is pretty bad practice. We should always be explicit about exactly which columns we want. So what I'm going to do is head back to the VB editor and write a comma-separated list of the exact column names I want. So rather than select star, I can say things like select film name, comma, film release date, and if I can spell that properly, there we go, film release date, and then comma film runtime minutes, and so on and so on and so on. So obviously this is much more tedious to do, but it's the best approach to be very specific about exactly which columns you want. If I were to run this one again now and then just have a quick look at the results, if I switch back into Excel, I've got the same basic pivot table, but if I look in the field list this time, I've only got the access to the fields that I've actually selected. Now, one of the really useful things about this particular technique is that your select statements can be incredibly flexible and dynamic. So I've got one particular pivot table here that shows me the average runtime minutes of all the films in the database. Maybe I'd like to compare this side by side with the films that have won an Oscar, or at least one Oscar. So to do that, I can head back to the VB editor, and in the same subroutine, I'm going to make a copy and a paste of those two lines, and then I'm going to change the string this time, so I add something called a where clause. So a where clause allows you to add filters or criteria to your queries. So this time I'm going to say where film Oscar wins is greater than or equal to 1. Again, I said it's not case sensitive, but I can't help myself. I've got to spell that with a capital O. So that will then call the same subroutine to generate a new pivot table with a new connection using a slightly different connection string. Sorry, not a connection string, a command text string. So if I run this one now, I should end up with 2 worksheets this time. And if I switch back and look at the first one, the average there was 126.71 minutes. If I look at sheet 24, the average of Oscar-winning films is 138.61 minutes. If I rewrote the code, I could have added both pivot tables to the same worksheet, but I'll just stick with the basic version that we've got here. Now, your where clause can include multiple different criteria, and it can also test multiple different data types as well. So here obviously we're testing for simple numbers, which you tend to use standard comparison operators like greater than and less than, etc. You can also test for dates and for text as well. So just to make a slightly different version of this, I'm going to copy and paste these 2 lines, and then I'm just going to comment out the previous 2 versions of that string. I'm going to focus here on testing for different dates. So all I really care about doing is showing the average film runtime minutes. So I'm going to take away the film name and release date from my select list. I'm also going to separate this onto multiple different lines just to make things a little bit easier to read. So I'm going to have a space underscore and concatenate that with the next part, which is just the from clause. I'm just going to indent that a little bit. And then another ampersand and a space underscore, and then have the where clause separated out there as well. In fact, let me just start my select statement on its own separate line too, so it just makes it slightly easier to read. So rather than testing for the film Oscar wins greater than or equal to 1, what I'm going to do instead is test where the film release date is between 2 dates. So I'm going to say between, and then I'm going to test for the year 2000, so that's 2000-01-01. SQL Server dates are entered as a string of text, so you use single quotes to delimit strings in SQL Server rather than double quotes like in most other Microsoft products. And you also enter dates usually in this format. There are several formats that SQL Server will accept, but a nice unambiguous one to use is this one where you specify the year first, then the month, then the day. So this conforms to an international standard. If you're wondering why I'm entering in this particular format, it looks a little bit unusual when you first encounter it. But SQL Server prefers dates in that particular format. Just to really quickly show you, this is ISO 8601 is the international standard. Would you believe there's an international standard which explains how dates should be formatted in computing? Well, this is the one that conforms, that dictates those standards. So it's year-month-day. So having done that, I can now say when it's between that date and between 2000-12-31. So, running this subroutine now, we'll get rid of the previous 2 sheets, and if I run it and have a quick look at the results, I'll end up with an average runtime minutes for all the films made in the year 2000. You can also base your where clauses on text columns, so if I switch back to the VB editor, and then I'm just going to make a copy-paste of that previous query, and then comment out the one that I've just copied. And then let's see, I want to base my new criterion on the film name column. So if you're looking for text that's exactly equal to, so let's say I was searching for all the films whose title was exactly equal to King Kong. So there are 3 King Kong films in the database. So say where film name equals, then again, because I'm using text in SQL Server, I wrap that up in a set of single quotes and then make that equal to the exact phrase King Kong. So if I were to run that one and then have a quick look at the results, I'll end up with a list that shows me all the films, or the average runtime of all the films called King Kong. If I then go back to the VB editor, let's have a look. Maybe I want to see all the films that begin with the word star, for instance. So to do that, I can use wildcard characters and a slightly different operator as well. So I take away the string of text here and say, rather than King Kong, I'm going to say star. That would at this point look for all the films whose name is exactly equal to the word star. What I want to do is find any film that begins with the word star, followed by any string of text after that. So to do that I use the wildcard character, which in SQL Server is the percentage symbol. I also can't use the equals operator anymore. What I also need to do here is change the equals operator to the like operator. So it's finding a pattern match. It's any film whose name begins with star, followed by any sequence of any characters. So that's a lot of Star Wars and Star Trek films, although we won't actually see those names. If I were to run this subroutine and then have a quick look at the results, that's the average running time of all those films. So that's a little bit to do with how you can write separate criteria or combine your criteria. You can of course combine your criteria. So if I wanted to find films whose name begins with star and was released in a particular year, I could simply add in an AND operator here and say AND film release date between these dates. So if I pasted that one in, and then let's just expand the date range slightly so it goes up to say 2005 or so. If I run that one, I'll end up with a different result. So that one's based on the films containing the word star, or starting with the word star I should say, released between those two dates. If you did want to find films whose names contain the word star anywhere, then you can use a second wildcard character, so a percentage symbol, then the word star, then another percentage symbol, so that will find the word star anywhere in the film's name. So that's just a few basic ideas about how you can write criteria. As I say, you'll get a lot more idea about that if you watch the SQL Server Queries video. Now, by far the most complicated and awkward part of writing your select statements inside your VBA code is when it comes to writing joins to put more than one table together in the same query. What we need to do to make that work is write a slightly more elaborate from clause to join our tables. Again, if you're interested in the detail of this, I'm not going to go into a massive amount of detail here, but the SQL Server Queries tutorial has a section all about joins, which you might find useful at this point. But just to give the absolute basics, if I switch back to my VB editor, I want to get to the stage where I can bring in the studio, certificate and country tables all connected to my film table. So to make that work, I'm just going to make another copy of part of this string. I'm going to copy everything up to the end of my current from clause and then paste that in down below, and then I'm just going to comment out that section of code just to keep it in there for reference, and then we'll make some changes to the from clause to bring in some extra tables. So if I want to bring in multiple tables, I've got to tell the query how those tables are joined together. To do that, I'm going to write after TBL film the words inner join. What I can then do is write out the name of the next table, which in this case I'll go for TBL country. I then have to say which columns those two tables are joined on. So I need to write the word on, followed by a list of the two columns that are joined together. If you think back to when we designed our basic view earlier on, we saw that there was a line that connected the different columns between the different tables. So this is what we're trying to specify here. We're trying to specify in this case that it's country ID, which is the column in the country table, is equal to film country ID, which is the column in the film table. Now, because those two column names are unique across both tables, I don't need to do anything special here at all. It's common convention in the real world to call the columns in the different tables the same name, so it would be country ID equals country ID. And if that was the case, I'd have to qualify the column name with a reference to the table to which it belongs. So I'd have to say TBL country dot country ID, similar to the way we specified the schema and database name earlier on. And then here I would have to say TBL film.film country ID. That's not necessary in this case, but just to demonstrate that this part will work, what I'm now going to do is bring in the, let's bring in the country name column into my select list, and then I'm going to quickly run that subroutine just to demonstrate that that will work, and head back to the Excel spreadsheet, click into the pivot table and show you that I've now got access to the country name column. So I could happily put that in the rows box. It will show me the average runtime for all those countries. So all I have to do now is carry on writing the code to join in all of the other tables. So back in the VB editor, just to make things a little bit easier to read, I'm going to separate out my from clause. I'm going to close the double quotes at that point, and then an ampersand, space underscore, and then begin my TBL film line on a separate line. After the words in a join, I'm going to close the double quotes again, and ampersand, space underscore, and then TBL country on those fields. Then I'm going to add in a space after film country ID, and then I'm going to have another ampersand, space underscore, and then I can list out the next table name. Now the reason I'm doing this is because the pattern for adding in multiple tables is exactly the same as the pattern that I've just followed here. So if I've said TBL film in a join TBL country, once I've brought in the country table, I'll need to write another inner join before I can specify the next table. So in this case I'm going to bring in, let's say, the studio table next, so that's TBL studio on, and I've got to refer to the column names. I'm going to qualify the column names with the names of the tables, just as I've done in the previous example. So TBL studio.studio ID equals TBL film.film studio ID. I can then bring in another table by saying inner join again, and then just to give myself a slightly neater layout, put that onto a separate line. And the last table that I wanted was TBL certificate on TBL certificate dot certificate ID, lots of potential for typos here, certificate ID equals TBL film dot film certificate ID. Nearly made a typo there. Nearly made 2 or 3. Sorry, film certificate ID. There we go. I don't need to bring in any more tables, so there's no need to write inner join, and I shouldn't write inner join at the end of that. All I need to do is close the double quotes, and that will now select all those 4 tables. So what I should then do is make sure that I've got access to the particular column names that I'm interested in. So country name, and then I also wanted to have studio name, and also certificate name. So that should mean now that if I've added in all those extra columns, I could scroll back up to the main routine and uncomment the section of code that adds in the row, column and page fields. If I just run this final version of this routine just at this point, then I should end up with now a new pivot table that now has access to all of those extra columns that I've just brought in. Now, although this is quite a powerful technique, it does of course require you to know quite a lot about how to write SQL in order to be successful. So there is a final way that you can cheat with all this. If you have access to SQL Server Management Studio, and if I just switch back into that, I can create a new query and then use the designer tool to generate the code for me. So making sure that I'm in the movies database, in fact I'm going to right click the movies database and choose new query, and that'll give me just a big blank page in which I can write out my SQL statements. If I prefer, however, I can right-click into the background of that page and choose Design Query in Editor. And what that will do is open up a dialog box which looks very much like the View Designer. I could of course use the View Designer to do the exact same thing here. So if I chose to put in, let's say, the certificate table and the country table and the director and film and language and studio just by double-clicking all those items, I should find that once those have all been added in, I'm generating the SQL code in the background down here. I just missed the language table, it doesn't really matter, I don't really need the language table. Then I can just go along and check the boxes for the columns that I want, so that'll be all the name columns, and then I'll go for film name and film release date, and also the film runtime minutes of course, and the budget dollars, and box office dollars, and Oscar nominations and Oscar wins. I could then add in a where clause, so I've got a little dialog box, a little table here to fill in, so I could change the order of the results. I could add filters, so if I wanted to find all the films that have won at least 1 Oscar, I could find the film Oscar wins column. There it is, film Oscar wins, and add a filter in that box. It says greater than or equal to 1, for instance, and you'll see that that will add into the code the where clause. If I then click OK, that will write all the code just directly into the background of that script. So then all I need to do is copy it all to the clipboard, of course, and then switch back to the VB editor. And then if I were to just modify what I've done here, so inside a single set of double quotes, if I just copy all of that and try and paste in what I've just copied, it'll go a little bit wrong because it's all separated out across multiple different lines, of course. But if I can just tidy things up a little bit, I could have my select statement on one single line, and then concatenate that with a new line character, and then put my select list in a different line, and that ends with a double quote at the end there. Let me just put a space at the end, and then I can have another ampersand and a space underscore, and then at the start of the next line I should have the from clause. So let's just scroll back to the left. So there's the from clause. So let's open a set of double quotes there, and then I'm going to change the indenting there, change the spaces, get rid of some of the spaces. It's kind of a tedious process this, sorry to make you sit through this process to tidy everything up, but it will be hopefully worth it in the end. So it's a case of just making sure you've got the entire string built into what looks like and will eventually become a valid SQL statement. So lots of ampersands and new line characters. Of course you could just concatenate it all into one single line if you preferred, or just shuffle it all around so it all becomes one single line. But hopefully we're nearly there. Just a couple more lines to go, making sure I've got all the characters in the correct place. Close or open a new set of double quotes there, then one more line just to go, one more final continuation character, and then indent all of this and get rid of those extra spaces. Okay, perfect. So appreciate that was quite a lot of effort to do, but it's sometimes a lot better than having to write out the entire select statement from scratch. So having done all of that, if I were then to just execute this subroutine one last time, I ought to find that I've got another pivot table based on the results of that select statement that I generated using the Query Designer tool. So that's a nice little way to cheat. Hopefully that's given you a few ideas about some of the things you can do with these select statements. If you like what you've seen here, why not head over to the WiseR website, where you can find loads more free resources, including these videos, some written blogs and tutorials, and even some exercises that you can download to practice your skills. Thanks for watching, see you next time.